Alright, example 5, it says randomly select a student who took the AP Statistics exam and record the student's score. Here's the probability. Find the probability that the chosen student scored less than 3. So less than 3 would be these two. So it could either be a 1 or a 2. We can't have both, right? It can't be a 1 and a 2. So we're just going to add those two probabilities together. And we get 0.422. Then it says find the probability that the student chosen earned a passing score, which is 3 or higher. So we have 3 different cases we're looking at. It could be a 4, a 3, 4, or 5. So we would just add those 3 probabilities together. So these two are actually complements of each other. So because I added the 1 and the 2 for the first one, I added the 3, 4, and 5 for the second one. If I want to double check and make sure I did it correctly, these two should add up to 1, because then that would be everything in this survey here. All right, next we're going to look at when events are not mutually exclusive, so when we have an overlap. Okay. So when they overlap, we add the probabilities of the two events, but then subtract anything that overlaps. Okay, so it says the probability that a student owns a car is 0.65, and the probability that a student owns a computer is 0.82. The probability the student owns both is 0.55. So if I want to create a Venn diagram, we're going to put owns a car, owns a computer. So it says student owns a car is 0.65. The student owns a computer. Oh, oops, I don't want to do that. I don't want to start there. I want to start with the overlap. Both is 0.55. So that's got to go in the middle. And then total, this whole circle should be 0.65. So if I take 0.65 and I subtract the overlap, then that gives me 0.10. So owns a car is 0.10. And then owns a computer would be 0.82 minus the overlap. So 0.82 minus 0.55 gives me 0.27. So this is just my work. I don't really need that there, but that's how we get those numbers. Okay, and then when you have a Venn diagram, you might also have something left over on the outside. Remember, these are supposed to add up to 1, so I need to see what these add up to. So I've got 0.1, 0.55, and 0.27. That doesn't add up to 1. I'd have to have 0.08 left over on the outside. Those are the people that don't own a car or a computer. Okay, so now it says, what is the probability that a randomly selected student owns a car or a computer? So when I'm saying car or computer, since they have an overlap, I have to use my new formula. The car plus the computer minus the car overlapping the computer. Right, so that's this formula. Car plus the computer minus the overlap. So just the car was 0.1, just the computer was 0.27. Oh, oops, nope. Sorry, the car was 0.65, the computer was 0.82, and the overlap was 0.55. So I'm going to add up those and subtract, and I get 0.92. Okay, what is the probability that a randomly selected student does not own a car or a computer? That was this outside here, 0.08. Alright, number 7 says, in a statistics class there are 18 juniors and 10 seniors. 6 of the seniors are females and 12 of the juniors are males. If a student is selected at random, find the probability in selecting the following. Probability of a junior or a female. So let's keep track of what we have going on first. So we have 18 juniors and 10 seniors. Of the 6 of the seniors are female. So 6 female means I have 4 males. And then for the juniors, it says 12 are males. So that would leave me with 6 females. So now it says if we have a junior or a female. So there could be an overlap. So I have to do the probability of a junior plus the probability of a female minus the probability of a junior and female. So if I want to figure out the probability that it's a junior, junior is going to be 18 out of the 28 total. And then the probability that it's female, there's 6 here and 6 here, so that makes 12 out of the 28. And then what overlaps? 6 of them are both junior and female, so minus the 6 that overlap. So now I'm going to add these up and subtract, and I get 24 out of 28. And then if I simplify or divide that, it rounds to 0.857. A senior or a female, so it's going to be the senior plus the female minus the intersection. So seniors, there's 10. Total females was 12. Minus senior and female is 6. So if I add these up and then subtract the 6, I've got 22 minus 6 is 16 out of 28. And then I'm going to get that as a decimal and get 0.571. Okay, a junior or a senior. This one's a little bit different because you can't be both a junior and a senior. So this one, I don't have to subtract anything because they're mutually exclusive. So I'm just going to add them up. So it's 18 juniors, there's 10 seniors, so that's everybody. So my probability is exactly 1 because they had to fit in one of those categories.